Hi students, so today we are going to study a topic in motion in a plane, and the topic's name is circular motion. Okay, circular motion. First we will study the reason for circular motion, and from the reason, okay, we will get into the concepts. Okay, the reason for circular motion, I will just consider a situation. Suppose if this is sun, okay, somewhere in the space some explosion happens, say for example, okay, some explosion, and from explosion different directions, okay, different big particles, I mean very big celestial bodies will move in different directions after explosion. Suppose, say for example, one body, it is coming in this direction, okay, this is coming like this. Now actually it is to be, or it is going straight, but when, if sun is here, definitely there is going to be a force of attraction, gravitational force will be there. Okay, so actually it wants to go straight, but gravitational force will be there. The resultant will be like it will bend in this direction. Now here also there is going to be gravitational force. Actually it wants to go straight, it will bend again. Likewise, okay, Fg will be there, it wants to go straight, again it will bend. So because of this gravitational force, okay, the resultant of tangential direction and this perpendicular direction will cause this bend. Finally what will happen? This celestial body will stuck up in circular motion, okay, not intentionally, but it will stuck up in circular motion. It will not be able to come out of circular motion. So there is a force towards the center, there is a force towards the center. Because of inertia it wants to go straight, but because of this force of attraction it will come towards the center. So this force towards the center, force towards the center is the reason for circular motion. Okay, any force, any natural force which is acting towards the center, and if a body gets stuck up in circular motion, then that force towards the center is the reason for circular motion. Okay, so here gravitational force is the reason for circular motion. Okay, so one term for force, which is generally any force which causes a circular motion, and if that force is acting towards the center, which is called centripetal force. Okay, the force towards the center is the reason for circular motion. This force is called centripetal force. So here in this case, this gravitational force is acting as centripetal force. So the centripetal force is not a natural force. The centripetal force is not a natural force. Centripetal force is a common term which is used in circular motion, or the force which is responsible for circular motion, or the force which is acting towards the center in circular motion is called centripetal force. So in this case you can see gravitational force is the reason for centripetal force, right? So note it down. Okay, now I will change the scenario. Suppose if this is a nucleus, This is a nucleus. Okay, suppose one proton is there. Nucleus, one proton is there. Okay, suppose you might have studied the Bohr model of atom. If an electron is moving in this direction, so what will happen? There is a force of attraction towards the center. Force of attraction towards the center. Correct or what? A force of attraction towards the center. So this electron wants to go tangentially in this direction, but because of this force, it will bend. Okay, so here the reason is electrostatic force. So electrostatic force acts as centripetal force here. Okay, the force between two charged particles, okay, or force between charges, okay, that is what is electrostatic force, which is acting as here centripetal force. Clear? So this is another situation. Done. Now suppose if there is a magnetic field, okay, a magnetic field is there, a positively charged particle, okay, a positively charged particle is entering into this field. So the direction of magnetic field is this. I am using right hand palm rule. These fingers are directing the direction of magnetic field. This shows the direction of magnetic field, these fingers. This thumb, the direction of this thumb is the direction of positively charged particle. If electron is given, then you should take the opposite direction. This is exclusively for positively charged particle or current. Then if I show like this, then this palm, direction of this palm is the direction of force. So magnetic force is equal to Q into V cross B. Okay, this is charge, this is velocity, this is B, magnetic field. Now how to find the direction of force? This is the direction of magnetic field, it is going inside. Now this is the direction of charge. Okay, okay, so now in which direction, now this is moving, okay, this is moving, in which direction force will act? This is the direction of magnetic field, this is the direction of positive charge, this is the direction of force. So force will act in this direction, this is the direction of magnetic force. So what will happen? A bend will happen. So again, if I do like this, this is the direction of magnetic field inside, this is the direction of velocity, force will be in this direction. So there will be a bend in this direction. Likewise, we will be getting a circular motion. If we consider here, this is the direction of magnetic field, this is the direction of force, this is the direction of charged particle, Q is moving like this. So this is the direction of force, this will be the direction of force. It wants to go straight, but bending will happen. So here magnetic force is responsible for this circular motion. So magnetic force acts as centripetal force. Okay, clear? Note it down. So any force, any natural force, whether it is gravitational force or electrostatic force or magnetic force, any natural force can act as centripetal force if it causes a force directing towards the center and which is responsible for circular motion. Clear? So this is the reason for circular motion. So there will be a force towards the center. Clear? This is the reason for circular motion, and any force can act as centripetal force, then there is going to be circular movement. Okay. Now before moving into the types of circular motion, we will study certain basics, then we will move into the types of circular motion. Okay. Suppose in order to make circular motion, okay, suppose if I consider from here, if it starts, after rotating it reaches here. So here, from here it starts, then it reaches here. So number of cycles per second, how many number of times, okay, this is rotating, okay, full cycle, how many number in 1 second, how many cycles are covered per second? This is called what? Frequency, or we say F. Okay, now the time taken for one cycle, is called time period. Okay, and this is nothing but capital T. Time taken for one cycle is called time period, and that is capital T. The relation between time period and frequency is T is equal to 1 by F. T is equal to 1 by F. Okay, now the unit of this is nothing but hertz, okay, denoted as Hz generally, and this is seconds. Okay, this is time, hertz, seconds. Now one more thing is there, angular frequency. Angular frequency omega, that is nothing but how many times, okay, or how many 2 pi are there in 1 second. That is what angular frequency omega, or we can say omega is equal to 2 pi f. So how many times this 2 pi is covered? Because from here if it start 0 degree, it rotates and it will come here 360 degree. So if frequency is, say for example 5 hertz, okay, so 2 pi will be covered 5 times here. Okay, so totally what will be the total displacement covered? Will be 2 pi into how many times? Into 5 times. So it will cover 10 pi. Correct or what? So that is angular frequency 2 pi f. This is also said as angular velocity 2 pi by t. Conceptually, angular frequency and angular velocity, definition wise or concept wise, there is some difference, but ultimately when we do problems or when we deal the situations, it works like same. So its unit is radians per second. Radians per second. So angular frequency, this is frequency, its unit is hertz, its unit is radians per second. Okay, already you might be knowing this, just I was touching the fundamentals before getting into the concept. Clear? Okay. Okay, next fundamental thing which we need to study is angular displacement. Angular displacement. Okay, so angular displacement is the angle traced by the radial vector, angle traced by radial vector or position vector, we can say. Angle traced by radial vector or position vector. Okay, so how could we say that? Okay, suppose if a particle is here, so what we say, this is radial vector, this is radius. Okay, the direction of radius, or we can say the position of this particle, we can denote like a r vector. Suppose if the position of the particle has changed to here, so this radial vector will be moving in this direction. Okay, so we will have to say that this radial vector is now here. So the angle covered by this radial vector is what? Angular displacement. Clear or what? Okay, angle covered by this radial vector is what? Angular displacement. Or simply I can say, suppose if I am standing here, okay, one corner of the class, one person, he is running to the other side. So now he is covering a linear distance. Suppose, okay, say for example, someone is running from here and he reached here. Now suppose if I am looking from here, he has covered a linear distance x. He has covered a linear distance x. But when I am looking, I will be looking like this. Okay, see, my pupil, my eye is just tilting. Okay, my eyes is just tilting. Okay, that is the angular displacement. What he has done, what he has covered is linear distance. Suppose if you are running, you are covering linear distance, but my eyes is covering angular displacement. Okay, so if this is x, okay, my eyes are tilting, this is what is theta. Clear? That is what is angular displacement. Now arc is equal to what? Arc is equal to radius into angle. Arc is what? Radius into angle. Now this linear distance x is equal to radius is what? Suppose if we take r, radius, into angle is what? Theta. So linear distance is equal to r into angular displacement. Okay, linear distance is equal to r into angular distance. Here I am going to generalize one thing. Anything linear is equal to r into circular. Okay, this is important. X is equal to r theta. Now linear is equal to r into circular means lot many places. Okay, whether it is linear displacement or velocity or acceleration, and even the relation between force and torque in many places. Okay, linear momentum, angular momentum, many places this r into circular equivalent will come. Linear will be equal to r into the circular equivalent. Okay, so many places, if you know this relation, it will help us. Okay, clear? So note it down. Angular displacement. Okay, right. So now the unit of angular displacement, the SI unit of angular displacement is what? Okay, SI unit of angular displacement is radians. Okay, that is pi by 2, pi by 3, we use pi. Okay, degree is also fine, but how it comes is 180 degree is equal to what? Pi radians. Suppose if you need to convert into radians, okay, 1 degree will be what? Pi by 180 radians. Suppose if you need to calculate some degree in terms of radian, suppose okay 30 degree, Okay, what we should do for 1 degree pi by 180, so for 30 degree pi by 180 into 30, so this will become 6, we will be getting as pi by 6 radians. I used 30 degree because all of you know 30 degrees pi by 6. How it comes is like this. So 20 degree, 25 degree, anything can be converted into radians through this method. Clear? Dimension of theta. Dimension of theta is what? It is dimensionless. Okay, dimensionless, because it is what we have written x is equal to what? R theta. Arc is equal to radius into angle, so theta is equal to what? X by r. So this is a ratio of distance and distance. This is actually, this angular displacement is dimensionally, this is a ratio of what? Distances. This is actually a ratio of distances. So it is dimensionless. Clear? Fine. Right. Okay, fine. Another question for you is whether this angular displacement theta, this is vector or scalar. This is vector or scalar. Okay, please think and tell whether this is a vector or scalar. Okay, so if this is a scalar, if your answer is scalar, then no need to worry about direction, but that is wrong. If this is a vector, then we need to know the direction. Okay, so it is a vector. Okay, theta is a vector. This is a vector. Okay, now suppose if there happens a circular motion, if a particle is moving from position A to position B, if it is moving like this, okay, so what kind of motion is this? This is anti-clockwise. Anti-clockwise rotation is going on. So what is the direction of this vector? Okay, its direction of the vector is what? So here we should understand that this is a vector, this is an axial vector. This is an axial vector, that is its direction is along the axis. Direction is along the axis. Direction is along the axis, that is curl the fingers. Okay, right hand thumb rule. Right hand thumb rule. Right hand thumb rule. Curl the fingers in the direction of rotation. Where this thumb is pointing, that is the direction of theta. Now when I curl the fingers in anti-clockwise direction, this is coming out. So the direction of theta is this, that is coming out of the board. Clear? Suppose if I do a clockwise rotation, if this is the initial position, if this is the next position, then curl the fingers in the direction of motion. So when I curl the fingers, I can see the thumb is going inside. So thumb is going inside. This is the direction of angular displacement. Clear? So this is an axial vector. Its direction will be along the axis. How to find the direction of angular displacement? By using right hand thumb rule. Move the fingers in the direction of motion. If this is the direction, then where this thumb is pointing, that will be the direction of angular displacement. And in this case, if you move the fingers in this direction, this is going inside. Clear? Note it down. Clear? Right. Next concept is angular velocity. Okay, angular velocity. So this is rate of change of angular displacement. Rate of change of angular displacement. So generally we know velocity, linear velocity is what? Delta x divided by delta t, rate of change of position, that is nothing but displacement by time. Or what we say, this is equal to, suppose this is average, we write delta x by delta t. If it is instantaneous, what we write? Dx by dt. Even if we get displacement function, we do what? ds by dt. Okay, so this we used to write like x2 minus x1 divided by t2 minus t1. If we know that a perfect time duration, what we can do? x2 minus x1 divided by t also we write. Okay, average velocity, instantaneous velocity, rate of change of angular displacement. So it is denoted as omega. So this is the case of linear. Okay, whatever we do in linear, just compare and study so that we need not remember anything extra. Okay, so here omega is nothing but, omega average is going to be delta theta divided by delta t, or theta 2 minus theta 1 divided by delta t, or instantaneous angular velocity is nothing but d theta divided by dt. Okay, so how fast the angle is traced, that is what is angular velocity. How fast the angle is traced, that is what is angular velocity. Clear? Fine. Now here, see, x is equal to r theta. We have seen this relation. That time I told you linear is equal to r into circular. Now let us see what is going to happen here. So v is equal to what? Dx by dt, that is speed is equal to rate of change of distance, velocity is equal to rate of change of displacement. Now suppose, let us consider here speed. Okay, now v is equal to dx by dt. Already we have studied v is equal to what? R theta. Now when I substitute here d by dt of r theta, now r is radius, so v is equal to what? I can take it this side, d by dt of theta. Now if the angle is changing, obviously theta is a variable. So already we have seen what is omega. Omega is equal to d theta by dt. Okay, instantaneous value. Then v is equal to what here? R omega. So if this is one relation, this is what? Linear, and this is circular. That is linear speed is equal to r into the circular speed. So here v is equal to r omega, linear speed is equal to r into circular speed, circular equivalent of speed. Okay, now what is the unit of omega? Unit of omega is radians per second, and the dimensional formula is t raised to minus 1. Radians, the unit radians doesn't have any dimensional formula. Already we said this is ratio of distance. Now per second is there, that will go up and t raised to minus 1. Clear? Right. Okay, so we have got x is equal to r theta and v is equal to r omega we have. Okay, so we will add formulas to this, to this list. Fine. Now what about omega is vector or not? Omega is vector or not? What is your answer? Okay, omega is a vector. Omega is a vector, and this is axial vector too. Axial vector. So just like generally the displacement, the velocity will follow the direction of displacement, same way in this case omega will follow the direction of angular displacement. Suppose if we consider an anti-clockwise motion, okay, so here if it is moving like this, the same technique, right hand thumb rule. Okay, if it is moving like this, the thumb is coming out, so we can mark this as coming out. Direction of omega is this. Suppose if it is a clockwise motion, okay, this is the direction of fingers, thumb is going inside, so this is cross, this is going to be the direction of omega. So omega is an axial vector, and this is how we need to take the direction of it. Clear? Okay, now regarding acceleration, lot of details to come, and one acceleration we know is centripetal acceleration towards the center, because wherever there is a force, there will be an acceleration. When there is a centripetal force towards the center, there should be a centripetal acceleration also. Its direction is also towards the center. All those things we will discuss. Now let us do some simple problems based on the concepts which we have discussed so far. Okay, so this is a question. Calculate the angular velocity and linear velocity of tip of minute hand of length 10 centimeter. So in clock, minute hand is there. We need to find the angular velocity and the linear velocity of tip of minute hand, okay, of length 10 centimeter. So suppose if this is the clock, okay, so a minute hand is there, so they are asking if this is the tip. Okay, this is the tip. So we need to find the angular velocity and linear velocity of this tip. Why this tip? Okay, there is some significance. Okay, pause the screen and do this answer. Okay, done. Alright, so first we will see angular velocity. So angular velocity, how can we find? If angular displacement is given, in that way also we can find, or otherwise 2 pi f, 2 pi into frequency, or 2 pi by t, or delta theta by delta t. Many formulae are there. So in this, which one is easy for us? They are saying this is minute hand. So starting from here, after doing full rotation, when it comes here, the time taken is what? time period t. So that will be the easy one to do this problem, right? So what is the time period of minute's hand? How many seconds minute's hand will take to complete one rotation? Okay, so after 60 seconds it will just move here, another 60 seconds it will move here, likewise. Okay, so 2 pi by, okay, how much time it will take to complete the rotation? Actually 1 hour. Okay, so 60 minutes it will take. Okay, after 1 minute it will just move here, after another minute it will move here, likewise after 60 minutes it will come here. So this is going to be, for every minute 160 seconds is it. So 2 pi into by 60 into 60, we will be getting 2 pi divided by 3600 radians per second. So this is the angular frequency of minute's hand. Okay, for angular frequency or for angular velocity, okay, it doesn't matter whether it is tip or this midway or here, because everywhere this is going to have same time period and same frequency. But when we come to linear velocity V is what? R omega. This R is what? Radius. So if tip is considered, then the total length we will have to take. So 10 into 10 raised to minus 2 into what? 2 pi divided by 3600. Correct or what? So this is how we will have to take. So if we want, we can simplify this. This is going to be 2 pi divided by 36 into, here this will go up 10 raised to minus 2, 10 raised to minus 4, 10 raised to minus 3. Okay, so pi by 18 into 10 raised to minus 3 meter per second. So this is going to be the linear speed, clear, or linear velocity, clear. So here suppose if they ask, okay, linear velocity of midway point of minute's hand, then we will have to take this length 5 centimeter. So answer will change. Okay, clear? Okay, students, solve this question. Okay, so propeller blades in aeroplane are 2 meter long. Compute the tangential velocity of point on blade midway between tip and axis. Okay, so pause the screen and do this. Try yourself. Okay, pause the screen and try yourself. Right, so I shall solve. Okay, hope your answer is ready. Try yourself always. Okay, so propeller blades, you know, this fan like rotating fan things will be there in the plane, that is called a propeller blades. Okay, many places, okay, we can see that. So any of the propeller blades you can imagine. So this is 2 meter long. So okay, so this is going to be 2 meter long. Okay, just this length. Compute the tangential velocity of point on the blade midway between tip and axis. Suppose if this is rotating like this, if it is rotating like this, this is what is axis and this is what is tip. Midway between tip and axis means it is exactly at the center. So this distance we can consider like r is equal to 1 meter. Now what about tangential velocity? In rotational motion, okay, if this angle how it is changed, okay, rate of change of that angular displacement is what is angular velocity. Linear velocity always happens where? Here. Okay, this is what linear distance and linear velocity, everything happens at the tangent. Okay, so here suppose if the particle is moving, if we draw a tangent, okay, whatever be the velocity in this direction, every point the direction of velocity changes. So this is what is tangential velocity, or nothing but linear velocity is what is tangential velocity. So this is linear velocity. This is also called as what? Or tangential velocity. Okay, so that is what, nothing new, only word is new, remaining all the things we know. Now what is the tangential velocity? V is equal to what? R omega, because it is rotating. Okay, and one data is missing. Okay, so one data is missing, dear children. Here I am really sorry. Okay, frequency I haven't given. Okay, here frequency is like okay, 1800 revolutions per minute. This is the frequency of rotation of propeller blade. Okay, frequency of rotation of propeller blade. This data I did not write, I'm sorry. So with this, just try, if possible, are you able to get the answer? Okay, so 1800 revolutions per minute, this propeller is rotating. Okay, propeller is rotating at 1800 rotations per minute. That data must be there. Okay, now right, we will solve. V is equal to R omega. So V is equal to what is R? Midway between the point. So let us consider here 1, and omega is what? When, since frequency is given, this is actually 2 pi f. So R into 2 pi f. So V is equal to 1 into 2 pi into frequency is 1800 revolutions per minute. So in order to convert that into SI unit, we will have to divide here per minute. So we will divide this with 60. So this is 30. So velocity is how much? 60 pi meter per second. 60 pi meter per second. That is the answer. 60 pi meter per second. Take the next question. Theta is equal to 2t square plus 2. 2t square plus 2. This is theta. Find omega in 2 seconds and omega at 2 seconds. Okay, so can you solve this? Pause the screen and solve this. Find omega in 2 seconds and omega at 2 seconds. Okay, done. Okay, okay, fine. So verify the answer here. So omega in 2 seconds, its meaning is like omega between 0 to 2 seconds. That is the meaning. In 2 seconds means in 2 seconds duration. Okay, in 2 seconds means 2 seconds duration. That is what the meaning of this omega in 2 seconds. So this means that omega average is what we need to find out. Okay, so this time we will have to do theta 2 minus theta 1 divided by the time duration is what given here. So in 2 seconds means 0 to 2 seconds. Here I will have to substitute 2 square plus 2 minus. So this is one thing. Now I will have to substitute 0. Theta 2 is at t is equal to 2 seconds. Now 2 into here 0 plus 2 divide by what? In 2 seconds. So that 2 I will have to write here. So this is what? 4 into 2, 8. So 10. Here if I take it inside, divide by 2. So 8 by 2 is equal to 4 radians per second. So that is the omega in 2 seconds. Okay, and next question is omega at 2 seconds. So when they say omega at 2 seconds, that is nothing but instantaneous value. Instantaneous value. How we find instantaneous value? omega instantaneous is d theta divided by dt. So in differentiating this, d by dt of 2t square by plus 2, if we do, this will become what? 4t. Okay, so omega at 2 seconds is what? Is equal to 4 into 2, which is nothing but 8 radians per second. That is the answer for this question. Clear? And now we will discuss about the types of circular motion. Okay, based on the types of circular motion, we can get into some other concepts also. Okay, so one is like uniform circular motion. One is uniform circular motion. So in uniform circular motion, suppose a particle is making circular motion, and suppose if the speed here it is 2 meter per second, here also 2 meter per second. So everywhere the speed is 2 meter per second. Okay, so in uniform circular motion we can say the speed is constant here. Speed is constant. Okay, everywhere speed is constant. Now when the speed is constant, okay, is there any acceleration in this motion? Is there any acceleration in this motion? Because here the speed is constant. When the speed is constant, my question is whether any acceleration is present in this type of motion. Okay, if your answer is yes, acceleration is there, what is that acceleration and what is the direction of that acceleration? Okay, if your answer is no, since the speed is constant, okay, magnitude of velocity is constant, there is no acceleration, then the answer is wrong. The discussion of circular motion, we started with the cause of circular motion. So there we discussed a force towards the center. If there is a force, then there will be an acceleration. Acceleration follows the direction of force. Acceleration doesn't follow the direction of velocity and displacement. Acceleration always follows the direction of force. So acceleration is there or not? Yes, acceleration is there. What acceleration is that? Centripetal acceleration is there. That is the acceleration responsible for circular motion. Because of this acceleration or because of the force responsible for this acceleration, it is making circular motion. So I could say, I could mark the direction of acceleration towards the center. Okay, force direction, acceleration direction, everything is towards the center. So I could say here Fc, centripetal force is there or centripetal acceleration is there. So in uniform circular motion, acceleration is present. This is nothing but centripetal acceleration. Centripetal acceleration. What about the direction? Direction is towards the center. Towards the center. The direction of acceleration is towards the center. Clear? Okay. Which force is responsible? Centripetal force. Centripetal force is responsible for centripetal acceleration. Okay, and direction is towards the center. Clear? Fine. Now one thing which we need to say is, here speed is constant. I already wrote speed is constant. In uniform circular motion, speed is constant. Speed is constant. What about velocity? What about velocity? I could say magnitude of velocity is constant. Magnitude of velocity is constant, but direction of velocity is varying. Okay, if I consider this point, the direction of velocity is this. If I consider this point, this is the direction of velocity. If I consider this point, this is the direction of velocity. This is the direction of velocity. Direction of velocity is towards in the direction of tangent. Okay, direction of velocity is changing, and this direction of velocity is what? Tangential. Okay, clear? Okay, note it down. Okay, so here suppose if we consider velocity, it has got two parts. One is magnitude, another is direction. Okay, so centripetal acceleration changes the direction. So we need not worry about that. So acceleration is already there, but why not velocity is changing? Okay, velocity is not changing. What is the reason? Acceleration is there. Okay, we need not worry like that. Centripetal acceleration is there, velocity is changing, velocity's direction is changing, magnitude is not changing. So if velocity is changing means, it doesn't mean that always magnitude should change. Direction change, then also we can say that velocity is changing. So centripetal acceleration is responsible for change in the direction of velocity. Important point. Okay, they have asked in the previous exams. Okay, centripetal acceleration is responsible for change in direction of velocity. Clear? So this is about uniform circular motion. Okay, centripetal acceleration is present. Clear? Okay, so now centripetal force. Okay, what is the general formula for centripetal force? mv square by r, mass of the body into its velocity square divided by r. Okay, then what about so here centripetal force Fc is mv square by r, centripetal acceleration AC is equal to v square by r, and their direction is towards the center. So this is all about uniform circular motion. Now if we take our attention to non-uniform circular motion also. Okay, so uniform circular motion, here I am writing centripetal acceleration. Why? Because only centripetal acceleration is there in uniform circular motion. Why I am specifying this is there are three types of acceleration in when we come to non-uniform circular motion. Okay, so now let us spend some time on non-uniform circular motion. Non-uniform circular motion. Okay, so non-uniform circular motion, suppose here if the velocity is 2 meter per second, here it is 3 meter per second, 4 meter per second, 5 meter per second, then 4 meter per second, 3 meter per second, 2.5 meter per second. So here the speed is changing. Okay, speed varies. Okay, speed varies here. Speed varies, or we can say magnitude of velocity. Magnitude of velocity changes here. Magnitude of velocity changes here. So here we have only centripetal acceleration. Okay, please remember this. Now in non-uniform circular motion, if we consider this moment, here it is 2 meter per second, immediately next point may be 2.1 meter per second, suppose if the velocity is increasing. If this is the case, then already we have a centripetal acceleration AC towards the center. In addition to this, if the velocity is changing in this direction, if velocity is changing in tangential direction, definitely there will be what? A tangential acceleration and tangential force. So I am marking here a tangential acceleration. So the source of tangential acceleration will be a tangential force. Okay, clear? So in addition to centripetal acceleration, there is a tangential acceleration. So when we come to non-uniform circular motion, already centripetal acceleration will be there. Centripetal acceleration will be there. In addition to that, what is also there? Tangential acceleration also will be there. Now if both vectors are acting in this direction, then net acceleration will be there. Okay, so the third acceleration we can say net acceleration of AC, centripetal acceleration, and AT, tangential acceleration. Okay, in addition to that, we are going to have another important concept called angular acceleration also. Okay, so angular acceleration is present in non-uniform circular motion. We will discuss about it now. Okay, copy this. Okay, clear? Shall I erase this? We will come back to all these concepts again. We will discuss their formulae. Okay, right now we will have a small introduction on what all accelerations are there in non-uniform circular motion. Okay, so number one, centripetal acceleration. Number two, tangential acceleration. Okay, now one more detail which I need to discuss on tangential acceleration is, suppose if I consider here a velocity v1, immediately just after this, if I zoom this, okay, just like if I am zooming this, just immediately next point, if this is v1, this is v2, that is at each and every point the velocity is changing. Okay, so if we need to find out tangential velocity, that tangential velocity at each point is changing in non-uniform circular motion. So definitely if we need to find the tangential acceleration, we will have to find instantaneous acceleration. So The formula already, centripetal acceleration we know, AC is equal to V square by R. But tangential acceleration AT will be what? Tangential acceleration is our normal linear acceleration which we have studied till now. Okay, just like G. Okay, that is constant. This need not be constant also. Okay, then what? Just we have studied about acceleration, right? In motion in one dimension, linear acceleration. This is like that. So this is dv by dt. dv by dt. Tangential acceleration is just like a dv by dt. If it is a function of time, velocity, we will have to differentiate. This formula we use in order to find instantaneous acceleration. Instantaneous acceleration, since velocity is changing at every instant and the direction is changing at every instant. Okay, tangential acceleration is nothing but dv by dt. Okay, clear. Now next one. Okay, then net acceleration of this is there. Net acceleration of AT and AC. Now fourth one we are going to see is angular acceleration. Okay, suppose here from here to this place we have seen theta and this is x. So theta is angular displacement. Angular displacement. Okay, then omega is equal to d theta by dt, or theta 2 minus theta 1 divided by t. Okay, now suppose if this theta, this angular velocity is not constant, in non-uniform circular motion this angular velocity will not be constant, because why this is instantaneous acceleration? Because if a force is acting in this direction, then only the velocity will change here. Same way, next instant force must act in this direction. So the direction of force is also changing, direction of acceleration is also changing, and direction of velocity is also changing in non-uniform circular motion. So in this case what will happen? Angular velocity also will change, because the movement of particle is changing its speed. So obviously what will happen? The change of angular displacement will not be constant, change of angular velocity will not be constant. So obviously if one point, if it is omega 1, another point this is going to be omega 2. So just like omega is equal to d theta by dt, angular acceleration is what? Angular acceleration is a rate of change of angular velocity, and it is denoted as alpha. Alpha is equal to omega 2 minus omega 1 divided by t2 minus t1, or alpha is equal to delta omega by delta t. So this is average value. Same way, alpha instantaneous means d omega by dt, d omega by dt. So we have got centripetal acceleration, tangential acceleration, net acceleration of these two. Fourth one is angular acceleration. Angular acceleration. Centripetal acceleration, its unit is these two are linear accelerations only, meter per second square, meter per second square. Here also meter per second square. But angular acceleration is a different type of vector, different type of acceleration. Okay, we will discuss that. Please note it down. Okay, so angular acceleration, alpha is equal to delta omega by delta t, and or this is average value. If we need to find instantaneous, d omega by dt. Already omega is what? Omega is radians per second. Here again time is there, so radians per second square. This is the unit of angular acceleration. Okay, radians per second square, unit of alpha, radians per second square, and its dimensional formula is what? T raised to minus 2. Clear? Now we have seen the direction of tangential acceleration along the tangent, direction of centripetal acceleration towards the center, direction of angular acceleration, that also we will see. Okay. Okay, so alpha is a vector, but what kind of vector? It is axial vector. It is axial vector. So if it is clockwise, okay, theta will be going inside, omega also will be going inside. Now here, if it is anti-clockwise, this is the direction, then dot, this is the direction of theta, this is the direction of omega. Now if suppose if the velocity is 2 meter per second along the tangent, or in the next immediate point, if the velocity is increasing, then we can say this is the direction of tangential force. This is the direction of tangential force. If this is the case, that is, if tangential force follows the direction of velocity or speed, okay, if the direction of velocity is this, movement is also this, if it is like that, then alpha will follow the direction of theta and omega. But see this case, if this is 2 meter per second, this is 3 meter per second. So in this case, the direction of tangential force is in this direction. Because it is coming like this, particle is coming like this. Particle is coming, this is the direction of particle here, but in the direction of particle, velocity is decreasing. So this you can see, velocity is decreasing. Velocity is decreasing means tangential force is acting against the motion. So in that case, here alpha will be following opposite to the direction of displacement and omega. Okay, that is, if the tangential force follows the direction of velocity vector, then alpha will have the same direction of theta and omega. If tangential force is opposing the motion or opposing the velocity vector, in the opposite direction of velocity vector, then alpha will have the direction opposite to theta and omega. Is it clear? So just find the direction of theta and omega, then based on whether the force is aiding the motion or opposing the motion, choose the direction of alpha. Okay, that will give us the enough details. Clear? Note it down. Okay, right. Now already we have written x is equal to what? R theta, and v is equal to what? R omega. Now what we should get? A is equal to R alpha we should get. So let us see, A is equal to what? dv by dt. So this is equal to d by dt of what? R omega. So in non-uniform circular motion, omega varies. So R is constant, R is radius, d by dt of what? Omega. So this dv by dt already we have written, this is nothing but tangential acceleration. So tangential acceleration at is what? r d by dt of omega is what? Alpha. So third relation, tangential acceleration is equal to what? R alpha. So this is actually tangential distance, this is tangential speed, so this is tangential acceleration. So this relation, this relation will be followed in this case not by centripetal acceleration. This is followed by whom? By tangential acceleration. So I repeat, okay, centripetal acceleration is v square by r. Tangential acceleration is either dv by dt or if necessary r alpha. Okay, and net acceleration is what? This is root of ac square plus at square. Okay, because this is vector. Okay, suppose if this is the circular motion, this will be the direction of tangential acceleration, this will be the direction of centripetal acceleration. So net acceleration will be in this direction. Based on this angle or based on this angle, we will be able to find the direction of net force also. Okay, so clear. We will revise in the next session also. We will do problems also, lot of problems based on this. First thing is uniform circular motion, non-uniform circular motion. Uniform circular motion, only one acceleration, centripetal acceleration. Non-uniform circular motion, four type of acceleration: centripetal acceleration, tangential acceleration, net acceleration of these two. Fourth one is angular acceleration. Centripetal acceleration, tangential acceleration are linear accelerations, normal vectors. Alpha is angular acceleration, which is axial vector. Okay, x is equal to r theta, linear is equal to r into circular, v is equal to r omega, at tangential acceleration is equal to r into alpha. Direction of theta omega alpha. Take the fingers in the direction of motion where this thumb is showing, that will be the direction of theta and omega. Theta and omega are axial vectors. If tangential force aiding the motion, then alpha will follow the direction of theta and omega, just like acceleration will follow the direction of velocity and displacement. If opposing the motion, then acceleration generally will be away from. Suppose if you are throwing something, gravitational force is acting downwards, acceleration will be acting downwards, right? Likewise, okay, if it is opposing the motion, angular acceleration will be in the opposite direction of theta and omega. Okay, so this is a brief introduction about circular motion. Okay, please revise this. Okay, do the problems we have done today, and in the next session again we will cover the problems based on all these. Okay students, hope you enjoyed the session. Thank you, goodbye, good luck.